In this video, we're going to use the quadratic formula to solve some quadratic equations. So here we go. Quadratic formula is up in the right-hand corner for you. When using the quadratic formula, a couple things to be careful of. First, make sure you put the equation into standard form, where ax squared plus bx plus c is all on one side and it equals 0 on the other side. Step 2, make sure you identify a, b, and c correctly. If it's in standard form, it's pretty easy to do that. Next, perform all operations carefully. That means be careful when you multiply and subtract and add and divide. Also, the simplifying part can be a little bit tricky. Make sure you simplify the radical part, then reduce fractions if possible. Let's roll. As I solve this quadratic equation, 4x squared minus 8x plus 1, my first thought from an earlier lesson might be, I'll try to use the British method to factor this. Don't write this down because you'll have to erase it, but here's what would happen if we tried to factor. Using the British method, I'd take 4x squared times 1, and I'd get 4x squared. Now, are there any factors of 4 that add up to negative 8? Absolutely not. So factoring is not going to work here. If factoring doesn't work, completing the square might work, but completing the square is kind of tricky, and I'd have to divide everything by 4 first, which would give me a 1/4 and make a big old mess of things. So probably a better method, and that better method is right here, the quadratic formula, because all I have to do is plug numbers into the right spots. So here we go. X is equal to, in the quadratic formula, I always start with the opposite of b. I like to say opposite because then it makes me know that I have to change this sign. So if b is currently negative 8, I'm going to use the opposite. Well, that's positive 8. Plus or minus the square root of b squared. Now, if you're good with squaring numbers in your head, you could take negative 8, square it, and write down 64. If you struggle with that, you might want to put negative 8 in parentheses and write that it gets squared. Again, those who struggle with mental math, I would recommend write down every single part of this before you do any kind of addition, multiplication, whatever it might be. Now, the next part, underneath the radical, I have b squared minus 4ac. It's always a 4 here. And then a is my leading coefficient, in this case, another 4. And c is the constant. In this case, it's a 1. So I'll write them all in parentheses to show that, hey, I'm multiplying these all together underneath one radical. And I divide that then by 2 times a being the leading coefficient. Once again, that's a 4. So 2 times 4 goes right here. Let's work on simplifying this expression now. Always start with the radical part first. So underneath the radical, negative 8 squared becomes 64. And I'll go ahead and multiply the other numbers together. I like to think of this as a negative 4. I think that keeps things positive and negative the way they should be. Be very careful with that. So I'm going to consider this negative 4 times positive 4 times positive 1, which is going to be negative 16. So essentially I have 64 minus 16. That, again, is underneath the radical expression. There's still an 8 out in front. It's still plus or minus the radical, and it's now all over 2 times 4, which happens to be 8. We continue to simplify the radical expression. So I still have 8 plus or minus the square root of, well, now it's 64 minus 16 is 48. So I've put those two things together, 64 and 16. Now I'd be done if my radical were simplified. However, the square root of 48 has a perfect square factor. So here's where we use our factor tree that we learned about earlier in the year. And the square root of 48, perfect square that goes into that. There's a really big one. It's 16. 16 goes into 48 3 times. The square root of 16 is 4. So 4, it's a little messy, I'm sorry. 4 times the square root of 3 would be the simplified version of that radical. So let's replace this with this. We write again, 8 plus or minus 4 times the square root of 3 all over 8. Now, the radical part has been simplified. That's good. Another part of the steps, remember, it said to reduce fractions if possible. Well, as I look at this, I'm dividing both 8 and 4 times the square root of 3 by 8. So the way that I like to think about simplifying this is I like to think about it in terms of a common factor. Looking at numbers on the outside and ignoring the radical part. This is done. But as I look at 8 and 4 and 8, I notice that there's a greatest common factor in those three numbers. That greatest common factor is 4. So I will divide out a 4, factor out a 4 from all three of these terms. Now what happens is, dividing 8 by 4, I get 2. Dividing 4 by 4, I get 1. So I don't have to write it because it's now 1 times the square root of 3. All over 8 divided by 4 is also 2. So 2 plus or minus the square root of 3 all over 2. Here is a good-looking quadratic equation answer by way of the quadratic formula. We'll try one more. So now I got 6x squared equals negative 4x minus 11. If you remember from the steps that are written up above, it said to write it in standard form. Well, that means everything is on one side and it equals 0. So I'm going to add these two terms to both sides. And a little cheat here to make it go faster. Okay, I'm adding that to that side as well. So we've got, for our equation, 6x squared plus 4x plus 11 equals 0. Now that my equation is set equal to 0, I can go ahead and use the quadratic formula to solve it. So in the quadratic formula, x is equal to, once again, the opposite of b plus or minus the square root of b squared. I'm going to do this quickly. 4 squared is 16. Minus 4ac. A is 6 and c is 11. All underneath the radical, all over 2a. Now simplifying this, oh boy, we've got negative 4 plus or minus the square root of 16 minus, doing a little bit of math on a calculator here, negative 4 times 6 times 11 is going to be negative 264. The square root symbol. So minus is 264. All over 2 times 6, so that's 12. When I take 16 minus 264, I am going to get negative 248. Now, I'll give you some problems with big numbers so you can see how to do it with big numbers. It won't necessarily be this big or this ugly looking, but you never know. So we're good, except we need to simplify the radical again, which is tricky, but we've had plenty of practice with it. So I'll use my little factor tree again. I'll write it maybe right here. Square root of negative 248. The negative part of this, well, it means there's going to be an I in my answers. I don't have to worry about the negative anymore. Square root, what big square goes into 248? Well, 4 goes into 48, so I bet you the square root of 4 goes into that. And doing, again, a little bit of division on a calculator, 62 times 4 is 248. So there's my matching factor. 62 I know is 31 times 2, neither of which factor is a perfect square. So this is okay. 4 is a perfect square that turns into 2. So I'm going to rewrite this as 2i times the square root of 62. That's the simplified version of this. Okay. So remembering what we got here, I'll use a different color. Here's what we're working with so far. X is equal to negative 4, still there, plus or minus. Simplified version right here. 2i times the square root of 62 all over 12. Simplified radical is great. Last thing to do would be reduce fractions if we can. 4 and 2 and 12 all share a factor of 2. So let's divide everything by 2. Negative 2 plus or minus 1i. I don't have to put the 1, I'll just put the I. Times the square root of 62. Again, if it's under the radical, it can't be touched. Divided by 12 times 2 is 6. Once again, simplified radical expression that's good as the answer of a quadratic equation. And that's good for now.